Let's quote for the next question. In the given figure, the radius of curvature of curved surface. So radius of curvature of the curved surface for both plano-convex and plano-concave lens is 10 centimeter. So plano-concave, plano-convex. This is plano-convex. This is plano-concave. So easily to understand. So we know that this is the convex lens and this is the concave lens. Okay. So this is going to be converging and this is going to be diverging lens, right? We know about these two very well from the class 10 itself. So here this is the plano. So we have to draw a plane. We have to draw a plane. Okay. Now we have to erase the any one portion. Erase any one portion from this. So I will be erasing this and erasing this thing. So now you can able to see whether the diagram is going to be as it is there in the given figure. So first this is the plano-convex and this is the plano-concave lens. You need to understand this thing very well. So next thing, so let us move to the next thing. So after learning this basic, so we have to understand now where is going to be the final image is going to be formed, where the final image is going to be formed. First of all, you have to find the where after incident here. So where the focal length in the principal line is going to be formed, the image is going to be formed here somewhere else. Okay, we have to find this f, the focal length of first lens and the focal length of the second lens, so that we can able to find the final v, that is total the final image. Okay, the distance of final image where it is formed. Okay, let us move and solve to the question. The first thing you have to solve here is the refractive index of the converging lens. It is a plano-convex lens. So this is going to be refractive index of the plano-convex lens. So we know that the refractive index for the both is 1.5 is given in the question. Okay, so n minus 1. First of all, I will be writing the formula for to find the refractive index with the help of the radius of curvature minus r1 minus r2. 1 by r2 is going to be the formula for to find the focal length with respect to the radius of curvature. So I will be substituting these values. So focal length, we have to find the focal length of this thing is f is equal to n is 1.5 for the both the lenses. 1.5 minus 1, I will be as it is, I will be writing 0.5. So 0.5 also can be written as 1 by 2. Okay, so 1 here 1.5 minus 1. Okay, this is 1.5, this is 1, right? So we will get 0.5. 0.5 we can able to write as 1 by 2. So radius of curvature of the first thing is infinity, because since it is the plane. So for the plane lens, the radius of curvature is going to be infinity minus. Okay, since it is the second curvature, it is going to be plus. So 1 by r2, the radius of curvature is 10 for both the lenses. So I will be writing this thing. So now, so we know that 1 by infinity is equal to 0. Okay, right? So what is going to be the answer is, so 0 plus 1 by 2 times 0 plus 1 by 10 is going to be 1 by 10. Finally the answer is going to be 1 by the focal length of this plano-convex is equal to 1 by 20. 1 by 20, which gives rise to focal length is equal to 20. Okay, and also we have to calculate the other one also. So since it is going to be related with the radius of curvature and the refractive index, both radius of curvature and the refractive index is same for both. So the focal length is going to be same for both the lenses. So I will be writing the diagrammatic form, I will be drawing the same thing, I will be saying the same thing here. So when the image is formed here like this, so first of all, so the light enters, so focal length, the light is going to be converged here at the focal length. Okay, since the distance between these two things is 10 centimeter given in the question, but the focal length is 20 centimeter. So when the light incident here, it travels up to the, so I'll be drawing the focal principal axis here, principal axis. Now this point at where it touches the principal focus is 20 centimeter, 20 centimeter. Okay, so this is the thing we have to know, this is the focal length of this thing. So and also focal length of this lens is also going to be 10 centimeter. So after 20 centimeter, so see from here the distance between the second lens, that is plano concave lens, and this point where the image is forming, the distance between these two things is going to be. So how you can able to find it? So this is given in the question, this is the distance between these two is 10 centimeter, and the light travels up to 20 centimeter. Okay, 20 centimeter. Now 20 minus 10, the remaining distance is going to be exactly 10 centimeter, exactly 10 centimeter. So where the object is formed for the second, for the second lens, that is plano for this lens, is 10 centimeter. Okay, the image, where the image of this lens is going to be the object of the second lens, the image of first lens is here, forms here, it is going to be the object of the second lens. Okay, plus according to the sign convention, this is going to be plus. Okay, now we have to find the image formation from the second lens, so this is going to be the important thing you have to understand. So say the focal length of both the lenses, for first lens, now we should not see the first lens, now we have to see the focal length of the second lens. in since we have crossed the first lens, now the image has been formed by the first lens, now this image is going to be act as the object for the second lens, where is going to be the image is formed. Now focal length of the second thing is going to be the same as 20 centimeter. Okay, 20 centimeter you can able to find using this formula, that is the lens formula, you can able to use very exactly, you can use the lens formula here. So lens formula, 1 by v minus 1 by u is equal to the 1 by f, this is the focal length. Okay, now we can able to convert this to find v. Yes, to find v, we have to write it as 1 by v is equal to 1 by f plus 1 by u. So we can able to convert this equation, 1 by v is equal to u plus f by fu, f multiples of u. So then finally we get v is equal to f multiples of u by u plus f. So using this formula we can able to find the final answer. Now by substituting the values here, so u is equal to plus 10, yes, u is equal to plus 10, v is equal to, u is equal to plus 10, right, plus 10 multiples of the focal length is, we have calculated the focal length of both the lenses first itself, that is 20 centimeter first itself. In the first page itself we will be having the same thing, so I will be moving on to the first page to show you that. Yes, yes, okay, okay, 20 by, the focal length is said to be 20 plus the distance of the object is 10. Now by simplifying this thing, so v is equal to 200 by is 30 is 0 0 get cancelled, finally 20 by 3. Sorry for the mistake. Since here the focal length is in the right hand side, right? So according to sign convention, f for this thing, sorry, left, from here to left, it is the image is going to be found from here to the left. Okay, so the focal length is going to be in the left direction, so always we have to write for focal length should be written in the subtraction form, so that's why the answer is wrong here. Now yes, focal length is in the negative form, negative sign, negative sign, and this is going to be 10, and focal length is always negative sign, right? This is minus 20, so v is equal to minus 200 by minus yes 10. So 0 0 get cancelled, minus minus get cancelled, finally the value is 20. Okay, why? Because the focal length is minus, because it is going to be in the left hand side only. Okay, we have to calculate when these two lenses are present here, the focal length is going to be calculated in the left hand side of this lens, that is plano concave lens, second lens. Okay, that's why we are taken as subtraction.